Does your advisor change every semester? Or does it stay the same?
Does my what?
Do your advisors change?
Advisees change. Oh, advisors. Your advisor only changes if you ask to be changed, or if you change your major. Yeah. So I don't remember you getting an appointment for pre-advising. Have you done that yet?
Mm-hmm.
Huh?
Mm-hmm.
No. Say it one more time.
No.
Okay. So don't whine when I'm not here next week and you need to get advised, because I'm not going to be here next week. Well, after Thursday. So you need to get, and I do mine on every Friday because I have it open from 9 to like 1. So look on the Starfish and sign up for a time this Friday, because this Friday is going to be it before, I think it's the 10th that you actually can register. That's why I wanted the dual enrollment students to find out. But then again, I think since it's summer, I think you're pretty much on your own, but you need to ask your dual enrollment person in high school. You need to ask them, say, look, what if I want to take a class during the summer? They'll probably tell you, you just need to sign up for it. But write those two down. And it's very important that you write them down and write down the example. Because remember, what does discrete mean? What does discrete numbers mean versus continuous?
And they have an ending.
Exactly. One is blank and one is blank. What is discrete? I gave you examples of discrete. I'm sorry, what?
Finite.
Finite? What's an easier word? Starts with the word C. Count. You count discrete. What do you do to continuous? Starts with an M. Measure. Now, of course, you're not going to do a lot of units of measurement with probability distributions, but you need to have that in your brain so you'll know what's going on. And I'll get to that in just a minute, because first I got to go to the whiteboard and kind of go through a little bit of Hubie presentation before I get into the actual mathematics. Okay, so one's countable, one's not. One has infinite many values, which means you have a lot of decimals most of the time, and you might want to put decimals, because most of the time your probability distribution is not going to be in terms of fractions, it's going to be in terms of decimals. And those decimals may go usually to 4 places. Okay, so I'm just going to go to the whiteboard here, because I think you had enough time to at least get that much down. I can't find it. There it is. Takes a while for the effects to wear off. No sneezing in class. You're disrupting the class. All right. So, let's go back to chapter 1. Let's go back to unit 1, or not chapter 1, chapter 3. And I told you there was 2 types of data. Type A is like test scores, 25, or ages. The 26, 26, 30, and 35. And what I called that like data. Okay, like test data, like whatever you want to call it. And then I told you that there was the second type, which is what? Not a probability distribution, but a what? A frequency distribution, which is nothing but a 25-cent word for what? A table. Okay, so 20 to 24, 25 to 29, 30 to 34, and 35 to 39. And head count is over here, and 0, 3, 1, and 1. Okay, so this is what we call M. Well, we're later going to call it M, but X and f of X, meaning this is your, I'm going to call it M. Well, later on, we're going to call it M. We're going to get the midpoint and use the midpoint, and f of X meaning the head count. Now, what did I tell you was the two most important numbers you could get out of this information? The mean, good, and the what? Standard deviation. Now, this is chapter 3, unit 1. We're in unit whatever, okay? Unit 3, chapter 6. What does this have to do with anything? Well, in this chapter, we're going to be introducing to you a a binomial distribution. And we're going to have let's talk about the World Series. Something I never watch because I'm not a baseball fan, so I never watch it. Anyway, what is the chance that the World Series will go to 4 games, 5 games, 6 games, and 7 games? We all know that they would love for it to go to what? 7 games. Why? More money. Okay? So, what is the probability of the games actually happening? And then we'll have something like 0.2. Now, I'm doing to the single digit because I'm not going to sit up here. I'm not Rain Man. I'm not going to sit up here and try to add 4 decimal places in my head. So I'm not going to do that. 0.7, 0.1, and 0. And that is what you call a binomial a probability distribution. Write that down. A probability distribution. Now, the numbers on the right can either be discrete, meaning what? Whole numbers. Or they can be what? Continuous, Hubert. Yes, meaning what? Decimals. Now, if they're whole numbers, it's going to be pretty simple. It can either be 0 or what? 1. But since they're decimals, you have to test it. You have to go through and test it. Each one of these x's has to be between 0 and what? All right, that's the first test. So if I have a negative up there, you automatically know, just cross through the whole problem and say cannot be done. Capisce? The second one is that the summation of all your x's has to equal what? 1, meaning 100% or 1. The summation of your p of x, has to be equal to, and I'm going to put an approximate. Let's use an approximate here. Some books do not use an approximate. Some do. Your book, I think, and you have to look in your little green boxes, they'll tell you. Most of the time, it's going to be between 0.9999 and 1.001. Because sometimes the decimals they give you is equal to 1.00001, and that's close enough for government work. So, approximately 1, parentheses, 0.9999 to 1.0001. Now, you can verify that in your book. Just turn a few pages and look in one of the green boxes or something, and you should be able to see something about this right here. Okay. Now, we're going to go through different methods of how to find the mean and the standard deviation. And that's what 6 and 7, I believe, because the reason I have to look at my outline is because the old book that we used to use did this a little bit differently. So I got to look at the, okay, 6, 7. Yeah, 6-1 and 6-2. We're going to be dealing with this guy. 6-1 and 6-2. Chapter 7, to me, we're going to be getting into the easier stuff. And that is the area under a what? Area under the normal distribution curve. Now, we're not going to get into calculus and the integration. We're not going to get into that. This is real simple math, okay? We're going to be using what's called the z-score, which y'all know, and the z-table in the back or the middle of the book. So, in Chapter 8, we start moving into the critical values. Okay, so that's what it. So you've got a kind of a melting pot in this section. 2 sections in 6, 2 or 3 sections in 7, and 2 or 3 sections in 8. But Chapter 6, we're going to be studying the probability distribution, and that's what this is right here. Okay? I want to give you one other example, and then we'll move on, because I want you to understand what a probability distribution is. I think it's very important. Let's say that a couple I'm not going to write every single word, been trying to have children goes to a specialist, finds probability of a girl to be 0.45. Okay? And this usually is worded in kind of an experimental type question. In other words, experiment, the research, blah, 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 experimentation, blah, 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 finds probability of a girl to be 0.45. I don't feel like writing all that, so I just wrote a couple been trying to have children, all right? Create probability distribution and find the probability of having 2 girls. Okay, now, first of all, you're going to sit there and look at it and go, I don't know where to start. Okay, well, there's a probability of having 0 girls. There's a probability of having 1 girl. And then there's a probability of having what? 2 girls. So you draw a probability distribution. The probability of having 0 girls, the probability of having 1 girl, and the probability of having 2 girls. Now, draw up your subset, or your sample set, or whatever it's called. Sample space, sample set. It's real easy. 2 children. Okay, y'all should be able to draw up a sample set. Boy, 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 girl, girl, boy, girl, girl. So draw that up and do it over to the side over here, because we're going to look at, so, boy, 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 girl, girl, boy, and girl, girl. Okay, everybody should be able to do that. Everybody should say, oh, that's no problem. Okay, now you have to apply what they have given you. What else have they given you what else have they given you in the example or in the question? What else did they give you?
Probability of 1 girl.
Probability of a girl is what? 0.45. What's it supposed to be?
45.
It's supposed to be 0.5, right? But it's 0.45. So evidently they found some kind of something wrong with you, or wrong with the father, or wrong with whatever, the lining up of the planets, and they're saying that it's 0.45. So what's the probability, therefore, and you should have done this, right? When they give you a probability of something, the first thing you should say is, well, then that means the probability of the opposite is what? Probability of not a girl or a boy in this case, because contrary to popular belief, there's only two freaking genders, okay? I don't care what anybody says, and they can fire me tomorrow, but you know, when you're born, except for 1% of 1% of the population, you're one of the two. I'm sorry, okay? Unless there's some kind of malfunction or something, you're one of those two things. All right? So I'm just going to go ahead and put probability of a boy because, or male, whatever. What is the probability of a male? I'm sorry, that's what I heard. 0.55. Where did she get that? Is she just a math whiz or what? No, she got the what? You can't say it like that. What did I just get? The what?
The compliment.
Compliment. Good. All right. So now I'm going to figure the probability for two boys. And what is the probability of two boys? Using your multiplicative, what is the probability of a boy and a what? And a boy. And means what? These are bodies. Can you replace bodies? No. So it doesn't really matter because you're going to do 0.55 raised to the what? Second power. What you going to do here? 0.55 times 0.45. Good. And somebody be doing this. I want 4 digits. 1, 2, 3, 4. 1, 2, 3, 4. These two will be the same because it's just commutative law. 0.45 times 0.55. And these two will be the same. And the last one would be 0.545 raised to the what? To the second power. So somebody give me the first one. Okay, it doesn't take that long. 0.55, caret symbol, 2. It doesn't take that long.
0.3025.
30, what?
25.
25. All right, give me these two. 0.55 times 0.45 is
0.2475.
2475. Is that the Russian?
Yeah.
Okay, somebody check that. He may be throwing a monkey wrench in our computations here. All right, what's 0.45 raised to the second power?
2025.
2025. Now, if you was to add all those up, what do you think you'd get?
1.
1. Go ahead and try. And is all of them between 0 and 1? Yes. 0.3, that's 30 cent, 20 cent, or 25 cent, 25 cent, and 20 cent. So if you add those up, you're going to get 1 or around 1. You have just formed a what? A probability distribution. The probability of her having two boys is 0.30 what? 0.032 whatever, 3025. Now, add those two middle ones up, somebody. 0.495, 0.50. What do you get? Does it come out to be 0.5 or 0.495 what? 0? And then the last one is 0.2025. And you just formed a probability distribution. Now I want you to mark this one on how to create a probability distribution because you may see one in your notes that tell you, your homework to tell you to create one. I do not ask you to create one on a test. The only thing, but I think it's kind of difficult to show you what a probability distribution is when I don't show you how to create one. So I think the best way to show you that is to actually create one. Capiche? Now the biggest part that you need to realize on this one is this guy. in order for you to create a probability distribution, you have to be given what? The probability. Okay? Other than that, what would you assume? That it's 0.5. And if it's 0.5, then you really don't have to, then you can go back to chapter 1 or chapter 3. Remember I told you to, no, what chapter we just came out of? 4? Huh? 5. Remember in chapter 5, I told you to print out a card and so with the sample spaces of 2 children, 3 children, 4 children, 5 children, or up to 7 children. Remember me telling you that? That's the difference between that section and this section. This section, there's going to be some kind of something that's not 0.5 when it should be. Okay? And that is what a probability distribution is. So make sure, part 1. Part 1, what do? You set up the left side right here. Now I set up that left side because there's only 3 possibilities. 0 girls, 1 girl, or 2 girls. Step 2, using the probability given, find the complement. And then once you do those 2 steps, then you can do the 3rd step, which is actually calculate your probabilities. Now you didn't have 2 and 3 in chapters 6 or 7, whatever chapter we were in, 5. In chapter 5, you didn't have this. You didn't have this, so you didn't have this because it was assumed to be 0.5, and all you did was go boy, 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 girl, girl, boy, and girl, girl. And then you said, okay, there's 4, so just mark through this. Well, over here, let's see, 1/4, 0, that'd be 1/4 or 0.25. And over here to be 0.5, 1/2, and 0.5. And then here, 2 girls would be 1/4, 0.25. Now that's what you did in chapter, what chapter was it? Chapter 5, I think. You just did that. Remember that question? And you just wrote down the 1/4 or the whatever. And see, now you're adding a little bit of a twist to it. Okay, now there's 2 other ways to deal with the probability distribution. We'll go back to the book and see which one, see if they do an NPX or seeing what they're doing. I don't know what they're doing because this book is fairly new. So I don't know how they line it out compared to the old one we used to use. So let's go back to here and go back to the next page. Identifying. We already talked about a probability distribution. There it is. Hola. There's the test. Now see, this one says 0 to what? 1. In some books, I remember one book, it might have been the last book we used, it had a note over here, had a little star, and it would say 0.9999 to 1.0001. So just look, we'll look on the next page and see if it says anything like that on the next page. But here, there's your probability distribution, and it's discrete, meaning that you only have what? 0, 1, 2, and 3. It's countable. Games in a baseball game. 1 girl, not 1.5 girls, but 1 girl, 2 girls. The count is discrete. Comprende? Now, this is a test question right here. So you might want to write it down, example 3. It's real simple. Which one of these is a probability distribution? Which one is not? A is not. Why? It's negative. So you need to write that down because this is a test question. How about this one? Well, 20 cent, that's 45 cent, that's 55 cent. 55 cent and 50 cent is $1.05. So this one's not. Why? Because it's over 1. So 20 cent, that's 45 cent, 55 cent, 86 cent, and 14 cent. $1. So C is your answer. That's the only thing I'll ask you pretty much about anything to do with the probability distribution. I will now the homework may ask you to create a simple one. I don't think I'd put a difficult one on there, but I didn't create the homework. But this is the first type of question I would give you on a test concerning the probability distribution. Somebody will still get it wrong. I don't ask about doing that. I don't graph probability distribution. Interpreting the mean. Well, the mean of a probability distribution is your summation of what? Summation of x, that's these guys right here, divided by n, which y'all know that. Okay? Summation of x divided by n. And that's what they're doing right here. So I'm not going to worry too much about that. Y'all know how to do that, but I'm not going to ask you that. Okay, here we go. The mean of a discrete random variable. Write that down. The mean is equal to, and that's mu, the mean is equal to x times p of x. That's a test question, because I'm going to ask you the mean. No, sorry. There you go. Let's move up just a little bit. And here's an example right here. Now, where do you think I'm going to show you how to do these? On a calculator or the spreadsheet? The spreadsheet. 2 reasons. One, because it's easier for me to keep everything on the board, as I told you. And second of all, that's the best place to do this. Okay? Because your calculator is not going to be able to do some of those things unless you tell it to do it. And I'm not going to go into the dissection of a TI-84 or TI-83 telling you how to multiply cells in your spread. I'm not going to do that. That'd just take too long. Okay? So I'm going to use the spreadsheet on this. And we'll do an example here in just a minute from your homework, but that's how you do it. Now, how do I find the mean? I multiply x times p of x. X is the count of girls. What is the probability of 0 girls, 1 girl, 2 girls, 3 girls out of 3 children? And then there's your probabilities, 0.01, 0.10, 0.38, 0.51. Multiply them, add them up. And that's your what? That's your mean. So your average, if you have a bunch of people having 3 kids, 2.4 of them or 3 of them or 2 of them, however you're going to round, in that case it would be 3. 3 would be whatever your probability is, okay? Well, you don't have to write this example down. You can if you want to. I'll leave it up there for another minute or two because we're going to do several of these in the homework and in your questions and on the test preview. So you're going to have at least 2 or 3 examples in your notes of me just going over an example, you sending in questions, and me going over the test. You're going to have at least 3 more examples. Capiche? Okay, write this down right. You don't have to write down this whole thing. You just might want to write down page 301, purple box, interpretation of mean. The difference between x bar and mu gets closer to 0 as what? N increases. What does that have to do with as n increases? What did we study about in the first part of chapter 5 or whatever chapter probability was? What did we study about? What's the rule of what? The 2 MIT guys with the roll of quarters. Remember that example I gave you? What does that represent? Starts with an L.
Rule of large numbers.
Rule of large numbers. That's where you get this from. The difference between the x bar which is the sample mean, and the what? What's mu?
Population.
Population mean. See, that's where those parameters come in. I know that's a sample mean because it's an X. I know that's a population mean because it's a Greek letter, mu, M-E-W. They get closer to zero. In other words, they get closer to equaling each other as N what? Increases. So, if you're a quality assurance director or vice president or whatever the title is at Michelin, are you going to pull 5 tires from each company, from each campus, or are you going to pull 5,000 tires? You're going to pull 5,000 because of the rule of large numbers. Okay, I'm not going to do that one. We're going to do some more examples later, so I'm not worried really about that. See, here's how you find the X bar. You add up all those numbers and divide by what? 100. And there's your X bar. Then you go through and do a probability. I ain't going to do a probability distribution on this because it'd be too much. Okay? And then you do that and you come out with, see if the two means equal each other. I'm looking for, all right. This is a homework question. I do not put it on the test, but you need to read it. Example, not now, but you need to read example 7. Make a note of it. It's in your homework. And all of this reading right here basically talks about, suppose an 18-year-old male buys a $250,000 one-term life insurance policy for $350. Okay? What's wrong with this sentence? Suppose an 18-year-old male buys a $250,000 one-term life insurance policy for $350. What's wrong with that sentence? Nobody knows what's wrong with that sentence? No.
An 18-year-old.
An 18-year-old male ain't going to buy no one-year life insurance policy. Okay? An 18-year-old male is like a buck in rut. He ain't going to be worrying about no daggum life insurance policy. He's worried about putting, what are those, the smokestacks on his truck. He's worried about putting thousands of dollars of audio equipment in a $2,000 car. He's worried about wearing sunglasses in the gym. He's worried about stupid stuff, all right? And very rarely do you have an 18-year-old worrying about smart stuff, okay? So, and I was 18, and until you get to be 25, 35, you're going to be stupid. So I'm sorry, that's just 18-year-olds. I'm sorry. Now, there are some that defy the statistics, maybe 2 or 3%. But other than that, you're a stupid male, okay? That should be like a 26 or a 36-year-old male. But what is the life expectancy of an 18-year-old male? They're stupid. So what's the life expectancy? Not very high, because they get into a car with over 300 horsepower. They don't know how to drive, all right? So they go down, and look, they will survive 0.9989. Now, you say, well, that's pretty high. Well, you ought to look at it compared to an 18-year-old woman. An 18-year-old woman is going to be higher than that. Okay? So, that's why they pick an 18-year-old male. I don't know why, but and most books, if you have a problem with a woman and a man doing the same job, in most books, which one does it better? The female, of course. But this problem is talking about being smart, and an 18-year-old male is not smart. So, sorry guys, I'm sorry, y'all are 18. I'm excluding y'all, of course, because y'all are exception to the rule, right? Y'all don't have smokestacks on your trucks, I hope. Please tell me you don't, and if you do, please take them off because you look like a damn idiot, okay? All right, suppose an 18-year-old male buys a $250,000 one-year life insurance policy for $350. According to the national blah, 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 the probability that male will survive is 0.998937. Compute the expected value of this life insurance policy, or this policy, to the life insurance company. Well, I'm just going to scan down. The first thing, did they give you a probability of a girl? Yes, there it is. So what's the probability of a boy? What's the complement to that? Well, 99 cent is 1 cent, right? So it's going to be 0.000 something, right? And where is that? What's that right there? That's the what? Complement. Probability of one dying. Okay, so you need to write those two things down right now. That's part one. Now, what's part two? Create a what? Starts with a T. Table. Thank you for interaction. I appreciate that. There's the table. Write it down. Now, the table, the left side of the table is going to be pretty simple. You either dead or you what? Not dead. That's it. Now, I know that's not politically correct. Either you are living or you are not living. There. How about that? So, if you live, you lose $350. If you die, you gain what? Now that's as a beneficiary. But what is the question asking? Not as far as the person, but as far as the insurance what? Company. So if the person lives, the insurance company gains what? $350. That's why it's positive. If the 18-year-old dies, then the company is out what? $249,650. Why isn't it $250,000? Well, the company took $350 of your money. So you got to take that out. So what is the probability of surviving? 0.99 blah blah blah. What is the probability of there is, now find the mean. How do you find the mean? You multiply x times p of x and you add it to x times p of x, and that's your mean. That's what they did right there, step 2. And that's $84.25. The company expects to make $84 for each old 18-year-old. Now, I want y'all to think about that because I'm going to be honest with you. Next to banking and next to Vegas, the owner of a Vegas casino, not a gambler, who makes a lot of money? Insurance companies. Oh my God. Okay? I'm supposed to have a heart attack right now, aren't I? That's somebody's cell phone. I'm supposed to go into some kind of conniption. Why? Why do they make money? Because think about that. How many 18-year-olds are in America? A freaking lot. Yeah. All right? Now, take 2%. No, let's take 10%. Let's be very optimistic and say that those 18-year-olds have some kind of level head on their shoulders. Okay? 10% of a freaking lot of people is a lot of people, okay? So you take $84, and that $84, once you give that to the insurance company, it's what? It's theirs. So $84 times a lot of 18-year-olds, and the life expectancy is 99%. You got to remember, an 18-year-old that buys a life insurance policy, are they level-headed? Yes. So they're going to drive decently. They're not going to be the guy, in the group, I went to Panama City last semester. How long did it take? It took me about 8 hours. There's always that guy that does that. Always that guy. Run. Girls, run away from this guy. I got down there in 3.5 hours. You're an idiot. You have deficiencies in your areas. You have self-confidence issues. Okay? There's no need to go 107 miles an hour on the interstate. Okay? You're an idiot. So, you have smokestacks on something. All right. $84. You take $85 and you multiply that by 1 million. Let's say 1 million 18-year-olds that have a level head on their shoulders.
$85 million.
That's $85 million. You see what I'm saying? Has anybody ever thought of the insurance companies? They make money. Okay? They do make a lot of money. And what they double dip. They take your money, and then what do they do with your money after they get it? They invest it. So they make a lot of money on your $84. They make a lot of money. And that's just an example. My house insurance, okay, is a lot. Okay? $1,000 every 6 months or whatever. How many homes are in the United States? A freaking lot. All right? Now, there's a whole lot more people there getting insurance. I would say it's probably 80% that have house insurance or home insurance. You're talking a lot of money. And what do they do with that money after they get it? They invest it. Now, why do they invest it? Because they want to line their pockets? No. Because what happens if you have a fire? They got to pay it. So they've got to be able to get that money in their pocket. And then once they get it in their pocket, they've got to do what? They've got to multiply it. They've got to make it grow. So they're not doing it. When I say they're making a lot of money, what I mean is they're investing it so when that $250,000 house goes down after lightning strikes it, they've got money to pay for that claim. You see what I'm saying? So that's why do your homework on the insurance companies. Insurance companies make money. Now, whether they pay their people good, I don't know that, but they make money. All right? So, and that's what that is right there. So the insurance company gains $84. You lose $84. And that's what so know how to do that. And 90% of doing this problem is just setting up the what? Table. So make sure you know how to do that. If you don't, then you're a failure. All right, standard deviation. Write that down. Now, don't write down 2A. I don't use 2A. I use 2B. Okay, so write down the second one. That's the one I use. The summation of x squared times p of x minus the mean what? Squared. And I'm just going to go over one little problem. I'm going to pull it up on the Excel spreadsheet, and then we're going to quit for today. That don't mean start packing up rudely, okay? You pack up when I tell you to pack up. Start zipping your book bags. That's so daggum rude. All right. I'll turn it back to the do-jigger in just a minute. Just hold on. I want to get this in here. All right. So let's say I got P or X, whatever, X, and I put in 0, 1, 2, 3. And then I put in P of X. P of X is equal to 0.38, 0.2, that's 0.58, 0.32, 0.22 is point what? Let's see, that's 0.68 or 0.58. What is that? 0.6, 0.7, 3, 4, 5. Nope. Hold on. Yeah. 3, 4, 5, 6, 7. 0.8. Somebody check that and see if that's 0.8. That's all right. I'll just check it. Y'all take too long. Yeah. All right. So if I want to find the mean, I got to take X and multiply what? P of X, Hubert. That's right, class. Thank you for the interaction. I'll do the first one for you. 0 times this. And I'll do the second one for you. That's going to be 0.2. Now you do the other ones. And then what do I do with those numbers? Add them. Thank you. Appreciate that interaction. So the mean is 1.24. All right? Now, if you wanted to find the mean, you would take 0, 1, 2, 3, add them up, and divide by 4. But that's going to be very inaccurate because you're just talking about, that's very inaccurate. 3, 4, 5, 6. 6 divided by 4 is 1.2 something. Okay? But now, the formula, I'm going to come back to this in just a second. Here's the formula. What does the formula say? Read the formula. Don't ask me. Don't say, what are we supposed to do? I'm going to tell you. Read the formula. What do you got to do? Well, we got the mean, so don't worry about the mu. We got that. That's right there. So I'm going to put right here, mu equals. All right? So we got mu. So what else do we need? We got P of X. P of X is right there. But what does this say? So we got to make a new column and call it what? X squared. So, and it's real easy. Just take 0 and square it. Okay, it's not rocket science, people. And then copy that down. And then I'm going to make a new column here. Well, I'm not going to make a new column. I'm going to make a column right here, and I'm going to call it X squared times what? P of X. X squared times P of X. And equals, and pick the right, please pick the right columns. X squared times P of X. And then what am I going to do with that? Well, I'm going to add it up, just like I did before. Control C, Control V. Okay, now I've got the summation of X times P of X, X squared. Now what am I going to do with it? I'm going to minus what? Mu squared. So I'm going to go down here, and I'm going to say equals 2.88 minus parentheses 1.24 raised to the what? Second power. And somebody tell me what that number represents. Not the standard deviation, but the what? Variance. Good. And the standard deviation is going to be equal to that number raised to the what power? 1/2 power. And you feel good about yourself. So you don't have to put too much makeup on your face and look like a Oompa Loompa. You know, orange face, white neck. You know what I'm talking about. All right? Guys, run. Run as fast as you can. If you see orange face and a white neck, run. That's psycho. Baseball bat to the headlights, key down the side, run. All right. Question, gripe, complaint. All right, you just have figured out how to find the mean and the standard deviation of a probability distribution. Will we do it again when you come back? Yes, we're going to do it several times. So right now, how many days you got left on your homework or your test? Today? Homework or test? When's the test due? Okay, so y'all need to be focusing on what? The homework and the test for Unit 3 or whatever unit we're coming out of. And we'll worry about this when? Wednesday, okay, or Thursday. Y'all get out of here. Have a good day. If you got any questions for me, I'll be up here.